So now that we're a little bit more familiar with coding in Unity and how it works, let's go ahead and add a script to control our player within the world. So there's two ways you can kind of approach the movement of a player within a world like this. And we'll investigate both of them. We'll investigate one way first, which is actually moving the player, and we'll investigate the other way, which is to move the world around the player, and see why we want to do one over the other. So to start off with, we'll take a look at how we can move the player within the world. So we'll create a very simple script. So to do that, we're going to go into our assets folder. We'll make sure we're at the top level of our assets here. We're going to right click, create a new folder that we will call scripts, because this is where we're going to store all our scripts that we're going to use. And then we're going to right click in here and create a C# script called player controller. And remembering, as we discussed in the previous video, you don't put a space in between your player and your controller, or else Unity won't know how to do it. And you capitalize your C, so Unity knows how to break this up into two different words. Okay, so we've got our player controller script. Before we go and add anything to this script, we're going to go to our player, and we're going to click and drag this onto the player in the inspector. So you can see now we have our player controller script is attached, so we know we're able to make some changes to our player. Okay, so let's open up our player controller script like this. Okay, so we've got our player controller here. Now we're going to first of all create a value that we'll use to modify how quickly is our player moving. So to do that, we'll just say we're going to create a public float. So a float is a number value that has a decimal space. So say we wanted to move our player by 0.5 every frame in the world, we would be able to use that using our public float that we're going to set up as the speed of the player. So a float will be any number, positive or negative, that has a point value attached to it. So 4.3, 7.158, all these other numbers, whatever numbers you can imagine. So we're going to create a public float that we're going to call move speed. Now there's a certain naming convention that we follow in general with values in Unity as well. So much as in our script where we had capital P at the start and then a capital C for the next word, when we're creating variables within Unity, generally speaking, you use a small letter for the first letter of the word, and then any subsequent words within it. So move space speed would be how you'd imagine this. You basically just put a capital letter for where you would have a break within the word. So if I save this and go back in to Unity, let it compile down in the corner, and then go to our player, now you'll see we have move space speed, and this has been capitalized the right way that it should be, and it's got a space in it, so it makes it much easier to read in your screen down here. Now of course, if you want to, you can always just use all small letters the whole way. The only problem with that is when we go into Unity doesn't know that you want to do that in your head, so it just joins them up as one big long word and makes it harder to read. And especially if you want anyone else to work on a project with you or anything like that, it makes it harder for anyone else to understand what's going on. It might only slow it down, so you might look at that and it might slow you down by half a second to work out what that word is, but those little half a seconds add up and add up over time and make everything take longer. So it's much easier to just capitalize your words in the middle of words like this. So okay, so we've got our public float move speed. This is how fast we're going to move the player. The next thing we're going to do is reposition the player every single update frame. So we know void update here takes place every single frame on the screen. So how are we going to move the player? Well, we also know, as we discussed before, that the transform is what controls the position of the player within the world. And we want our player to move forward, so if we drag him forward like this, you can see, oh, our z-axis is what's changing. So, hey, maybe we want to make our z-axis move forward, go to a greater value. So basically what we want to say is, every single frame, move the player according to the move speed on the z-axis. So we can access the transform position of the player very, very simply, because all we have to do on the script is just type in transform dot position. So what we're saying here is, okay, we have our transform position. What we want to do now is set it to be equal to a new value. And the new value we're going to set it to be equal to is, first of all, a new vector tree. So a vector tree is a tree number value within Unity. If I just hover over this, we'll see, oh no, it doesn't tell us there, but it's basically a tree number value. It has an X and a Y and a Z. So if we go back to Unity, we have the X, Y, and Z positions. So basically this position value here is a vector tree because it has three numbers that it's storing for the position of the player. So we want to create a new vector tree which has an X, Y, and a Z value. So the X value, we know, hey, we don't want to change that from whatever it is at the moment, because if we're moving this guy back and forward on the Z axis, you can see the X isn't changing and the Y isn't changing. So we don't want to change either of those. We want to leave them the way they are. So for the X value in here, we'll just say, okay, just take in whatever is currently the transform dot position dot X. So whatever our transform position X is, don't change that. Then for transform position Y, do the exact same. So transform dot position dot Y. And then we come to the Z position. Well, we know, obviously, we want to go from where our player currently is within the world. So we want to start off with our current transform dot position dot Z. So we'll take our Z value within the world and we'll add on the move speed. So that would be your logical next step. You would think, okay, we'll say we want our player to move at a speed of 10. We'll add on the move speed to our transform position and we'll see our player zooming off into the distance, right? Well, we can save this and go back in here. I just realized my little game view here is zoomed in a bit. I'm just going to zoom this out with the scroll wheel. We have nothing set for our move speed at the moment, so we'll set this, we'll put it at say 10 like this, and we'll see what happens. If I hit play, ooh, look, our player appeared here for a second and then disappeared. If we look at the transform position over here, it's going up a lot. It's going up really, really fast. And the reason that's happening is because every single frame, our little player here is moving forward 10 places. So that's the first amount of movement it makes. Then it goes forward to here on the next frame. But you can imagine if your game is running at, say, 60 frames a second, you're covering a lot of ground very, very quickly. So obviously you don't want to do that. But rather than having to go and tweak it to a very slow value, so if we wanted to put this at, say, 0.01, you could do that if you wanted to. And you see, oh look, okay, the player is now moving at a bit more of a reasonable speed. Maybe even, let's go a bit faster than that, 0.1. Okay, so you'd have to set your move speed down at a really low value. But that's not really very helpful, because what will actually happen with that is, if we just put this back to being 10, imagine you've got your game running on different people's computers. And obviously different computers can handle different speeds, and the same with different phones will handle different speeds as well. So you, for example, you have a 30 frame a second phone versus a 60 frame a second phone. If you're moving 10 places every frame, on a 30 frames per second phone, you will move 300 within the world. But on a 60 frame per second phone, you'll move 600 places within the world. So that's not very useful, because it's still happening over the same amount of time. So basically what'll happen is your game will be twice as hard for anyone with a more powerful phone. But you don't want that. That doesn't make any sense. So instead, what we'll do is we'll go back to our script and we take our move speed here, we'll put a bracket around it, bracket before and after it, and then we're going to multiply our move speed. So we hit a little asterisk is how we say multiply. We're going to multiply this by time dot delta time. Delta time, there we go. So what is time dot delta time? Time dot delta time is basically just how long it takes to get between one frame and another. You see, when we hover over here, it says the time in seconds it took to complete the last frame. So basically, every single frame will take a tiny fraction of time. For example, if you're running at 60 frames a second, it'll take 1/60th of a second. If you're running at 30 frames a second, it'll run at 1/30th of a second. So now, basically what we'll have is, we'll have our move speed, which is, say, 10. If our time.delta time is 1/30th of a second for 30 frames, basically we'll have our move speed will be multiplied by 1/30, or basically our move speed will be divided by 30. So every frame, instead of 10, we'll move 0.3. But if it was 60 frames, we'd move 0.15. Which means that over the course of a whole second, no matter what your frame rate is, your player will always move 10. So we'll have our move speed will now always be, our character will move 10 places in 1 second, no matter what. So we can save this now, go back in here, and we let that compile, and we hit play. And there we go. We can see our player is moving off into the distance. So no matter what frame rate we have, we always have a consistent movement now. So that's all fine and dandy. We got our player moving off into the distance as much as they want to. The only problem with this is, as our player moves further and further off into the distance, the value can get really high. So if you get your players playing your game and they keep going forever and ever, and they keep traveling really far in your game, or maybe you want your players to go really fast. Say you want your move speed to be 1,000 every second. So we can hit play, and the player would go off flying into the distance, and very quickly you get a very big number on the z-axis. Now the only problem with this, I'm going to put this back to 10 because we don't really want that. The only problem with this is, when you start getting really big numbers within Unity, or within any kind of computer environment in general, because we're using a float value, when it gets to a really big number, it starts to get inaccurate. So what you would have is, your player will get really far, and then they might start hitting objects before they even touch them, or they might start hitting objects that they think they have gotten past that object, but Unity's, or the computer's physics, will go, oh no, you hit that object, because the float value of on the z-axis was so big, it didn't actually know exactly where the player was. So you can get weird errors, and obviously you don't want that happening. So that's why, instead of just moving the player forward as we go, what we actually want to do is move the whole world in the other direction. So rather than making the player travel along this way, so you'll see him moving the game screen here, what we'll actually do instead is keep the player in the same place the whole time, and instead we're going to drag the world back this way. So effectively what happens is, it looks like the player is still moving as we go, but now we're going to have the world coming towards us, and all the obstacles that we see in the world coming towards us too. So in our next video, we're going to take a look at how we can set up a script that will move our objects in the world.